Reaction mechanism can get difficult. We give an overview here. It will help you connect the various concepts in reaction mechanism, and you should keep it handy and may want to return to it periodically. Organic compounds all look the same with carbon, hydrogen, oxygen, nitrogen, etc. And you already read that the reactions depend upon the functional group, the single double bonds, the chain of molecules, etc. So it helps us to understand, will this reaction happen? Which of these compounds is most reactive towards HCl? Which of this is most basic? And such concepts. This is one very important concept in reaction mechanisms. Organic compounds are covalent, but there is electronegativity difference between the atoms in the compound. So for example, in this chloromethane, there is an electronegativity difference between carbon and chlorine. And the chlorine therefore attracts the electrons towards itself, giving it a partial negative charge and a partial positive charge on carbon. And this makes the chlorine more susceptible to attack by positive reagents. This is another very important concept in reaction mechanism. There are four types of electronic effects: the inductive effect, which is transmitted through the sigma bonds, the mesomeric effect, which is transmitted through the pi bonds, the hyperconjugation effect, which is transmitted through the overlap of sigma and pi bonds, and the electromeric effect, which is a temporary effect in the presence of an attacking reagent. So one important concept here is that the mesomeric effect is stronger than the hyperconjugation effect, which is stronger than the inductive effect. Here we give a visualization of sigma bonds, which you have studied in another chapter. This is a visualization of the pi bonds, and it is important to know this difference because the mesomeric effect, which is caused by pi bonds, is much stronger than the sigma bond or the inductive effect. These are pi bonds in a sp hybridization. So we see the pi bonds in the y-axis and the z-axis. In benzene, the hydrogen atoms join together in a sigma bond, and the alternate pi bonds create a cloud of electrons above and below these sigma bonds, and this makes benzene very stable. So basically, in reaction mechanism, we study about the electronegativity differences in the compounds and also the electronic effect because of the different bond structures in the compound. This is very important, and this will be discussed in great detail in subsequent videos. These polarized compounds get susceptible to attack by ionic or other polarized compounds. In reaction mechanism, we talk about reaction intermediates which are formed for a very brief period of time, and these are called transient compounds also. And then the reaction is concluded. Electrophilic reagents are reagents which attract electrons, and these are typically acidic. Nucleophilic reagents are reagents which are attracted towards protons, and these get attracted towards positively polarized atoms in an organic compound. We will also read about reaction intermediates, and here we show how these are represented. So free radicals, here the carbon has all the 4 electrons in its valence shell, but the octet is still not completed and it's a free radical. This is how it is represented. This is an example of a chlorine radical. This is a carbocation, and this is how it is represented. And this is a carbanion, and it has 1 extra electron, giving it a negative charge, and this is how it is represented. So these reaction intermediates are formed briefly during the reaction, and these are not seen in nature in free state. These are the main type of organic reactions: the substitution reaction, the addition reaction, and the elimination reaction. So in summary, organic compounds are covalent, they are not ionic, but there is polarity created because of electronegativity differences or because of the pi bonds, and this makes them reactive, and they react differently because of these differences. And reaction mechanism helps us to understand these differences and helps us to predict these reactions.